So we're here to talk through this TomTom puzzle by Murat. It has just 6s and 28s as clue numbers, which is why we gave it an almost perfect theme. Those are both perfect numbers and they fill in almost all the cages. There's one interesting deduction which you can almost see right at the start of the puzzle. You can't use it at the start of the puzzle, but it comes from recognizing the sum of the digits 1 through 7 is 28. A cage like this one is going to have to be a sum. But if we think about this cell and consider its value, say x, the remainder of this row is going to be 28 minus x. The same digit is going to be in these two shaded cells, and often in puzzles that have extended geometry, cages that almost fill rows, these kinds of hooks will exist. The quicker way to start in this puzzle is to look at these large 28s that are in very small cages. There's 3 cells. That implies in the puzzle like this that these are products. Even a cage like this, which can be 7 plus 6 plus 7, 20 is still far less than 28. 7 plus 6 plus 7 plus 6, 26, still less than 28. These 4 must be products. The 28 here actually can right now be either, so we will come back to that in a bit. But as products, the straight groups have to be 1 and 4 and 7. 1 and 4 and 7. This product, if we think about the factors of 28, can be 1 and 2 and 4 and 7 in different ways. So the only digit remaining in this row that's relevant to a 28 product is a 2. That will leave behind 14, which must be 2 and 7, which looks like this. The next thing to probably do is, again, look at leftovers. If 1, 4, and 7 are in these 3 cells, 2, 3, 5, 6 in some order are top. Those sum up to 16, and this will be a summation group. 16 leaves behind 12 more. 12 in a puzzle of this size has to be 7 plus 5. There's no other combination that gets you there. And there's already 7 that would be in this row. So the 7, 5 goes in like this. We're left with a 3, 6, 3, 6. 2 next things to do, they both involve either of these 28 cages. We'll start with this one. This 28 product needs a 7 somewhere in it. There's 1 cell left for that. The remaining digits need to be 1s and 2s and 4s. 2s aren't in this row, so 1 and 4 in this row. That now completes 28 as a total product. So we have to fill in the cage like this. 1, 4, and 7. We have a 4 that must be in that cell, and then 1 and 7 are in either of these cells. Some good progress in the puzzle. When you hit a sticking point like this, you'll sometimes want to consider maximal or minimal values of cages. This 28 is pretty much a maximal value. Way to see that is to start by looking in maybe these 3 cells, get a lot of the sum fixed. 7's already taken, so the maximum value these cells can have is 15, which would be 6 and 5 and 4. If those are just 15, there are 13 left to fill in. 13 can be 6 and 7, but it's not going to be 3 and 10. So we see 6, we see 7, we have a 4, 5, 4, 5, 6, 4, 5, 6. That a 4 is now here means that this digit's a 1. The 7 has to be on the bottom because of the 7 already in the grid. Get 2, 3 in here. We're now almost to the point that we can think about these cages, but actually we are already to the point where we can think about these cages because this digit has to be a 3 because this row is otherwise filled. What numbers are left that can go in this cell? 2 and 5 and 6. Can a 2 or 6 be in this cell? No, no. This has to be a 5. As we said at the start, these 2 cells have to be the same so that this cage is a 28 sum. 5 and 6 filled in, puts in this 4. Now we have some pretty full columns that we can look at, but we've never ever looked to this point in the 6s that are all 2 cell cages. And it's helpful to actually map those out a bit. There's an interesting property of 6 cages which will be used in this row. A 6 can be 1 plus 5, it can be 1 times 6, or 6 divided by 1, however you want to think about that. It can be 7 minus 1. If the lowest value is a 2, it can be paired with a 3, 2 times 3, or 2 plus 4. There's no other value, 2, 5, 2, 6, 2, 7, 3, 4, 3, 5, 3, 6, those all cancel. And so one thing to recognize is that A 2-cell cage always has a 1 in it or a 2 in it. And when this column already has 2 values that have a 1, the 2 in this group has to sit here, the 1 in this group has to sit here. You actually get to where you can mark, although you can't do too much with it, that this cell is a 1 or a 2, because again, every 6 cage in just 2 cells has 1 or 2 in it, and the 1 or 2 can't be in this bottom cell. One more thing we can do, though, is recognizing that this 2 is paired with a 3 or 4. It also turns out both of the 4s are taken in this column, so this has to be a 3. And I think that's what we can do for right now. Once a 3 is placed, this cell, which had a 1 or 3 option, now only has this 1 option and this 3 option. We have a little more, like this 2-3 pair already exists in the third column, so there's a 5-6 left over, and a 5 is up here. 6 and 5. This cell is in a column that needs 2, 3, and 6. The 3 and 6 are taken, so this is a 2. This will be a 3. This will be a 2. This will be a 3. This will be a 2. The remaining cell here has to be a 6. We have 2, 6 to place in this first column, and the 2 to the right forces this option. We have 3 and 5 left over here. We have a few options down below, but let's sort of see what's left. And I actually put those notes in incorrectly. I'm seeing that our note that a 6 cage has to have a 1 or 2 is actually now impacted by placing that 2 there, so this is a 1. And 1 goes with 5, 6, or 7, so we actually get that these cells are 5 and 6, but this remaining 1 is a 4. 4 just can't be in these cells because 4 and 1 won't equal that total value. With this 1 placed, we get a 1, we get a 7. This topmost row needs to have a 1. This is the last cell left for it. Topmost row needs a 7. Last 4 to fill it out. This space needs a 3, 5, 6. There's already a 5, 6 over here, so this is a 3. This is still 5, 6, but there's a 5 right there. 6, 5, 6, 5, 6. Just working through my notes. The 5 forces a 5 and a 3 and another 3. One last 4 and one last 2, and we're through the puzzle. Hopefully you had a perfectly swell time solving it yourself, but if not, some of these tricks, like seeing how these cells are the same and also seeing how these products really wrap together and force a lot of the start. There's a maximal cage over here, and a little bit about just breaking down. A 6 may seem a pretty flexible sum, and that's true when there's only one isolated in space, but when you have multiple sitting together, this observation that they each need to have one fairly low digit, either a 1 or a 2 within them, and then those interact together pretty well, that the 1s force a 2, force a 1, force a 1, 2, get through to the rest of it. So hope you learned a little bit about this puzzle and about TomTom solving, and we'll see you again soon.